In this video, I'll show you how to use light fall-off to solve common lighting problems. If you've ever had trouble like evenly lighting a group or a scene, getting a background to be brighter or darker, or adjusting contrast on a subject, then you need to understand how light falls off, aka the inverse square law. Here I've lined up 6 Lego minifigs a few centimeters apart from each other against a ruler to help me demonstrate. I'm going to use this LED panel and set it off to one side. And I'm going to meter the light from the position of each minifig. The room is completely dark now except for the light from the LED panel. You'll notice straight away that the minifig closest to the light is very bright and the one farthest away is darker. Duh, right? We know this intuitively. The intensity of light drops over distance. But there's more to it than that. The light spread is also becoming more even. Let's measure. f9, f5.6, f4.5, f3.6, f3.2, f2.8. The difference in the intensity of the light between the two minifigs closest to the LED is 1 1/3 stops. Between the second and the third, it's 2/3 stops. Then it's another 2/3 stops, 1/3 stop, 1/3 stop. So the greatest fall off happens closest to the light. By the end of the line, the light fall off is more even. What does that mean in practical terms? I'm just going to take portraits, moving the flash further back each time and compensating for the light loss by adjusting the aperture value. I'll move the flash back like this. I'm just using a small softbox for this demo so it can fit in the frame, but I would typically use something larger like this. So here's a photo with the flash at its closest point to the minifig. I'm at f11. Look at the fall off happening on the side of her face and the shadows on her arm. I've moved the flash back and I've opened my aperture to f7.1. The light reaches further back, opening up the shadows on her face and arm. Now the flash is pulled back even further and I'm now shooting at f5. She's much more evenly lit than the first two photos. And now I have the flash so that it's completely out of my shooting area, about a meter away. I'm at f4. Much more evenly lit than from when the softbox was a few centimeters away from her. Side by side, you can see that the closer the light is, the more contrasty the lit subject is. Look at the side of the face in shadow and the cast shadow on her shoulder. The fall off of light at this distance happens quickly, so you get deeper shadows. Compare that with the shot at f4 with the flash further away. The shadow transition is bigger. So by positioning the light further away, you can achieve more even lighting and lighter shadows. Of course, the different light modifiers change the shape, softness, and intensity, but the inverse square law will still be in effect. Another common use of the inverse square law is to change how bright or dark your background is. But let's take a step back to the first clip, this one that was shot in natural light. What's happening here? The roof window is to the right, just about where I held the flash for the last portrait shot, but the indirect sunlight is evenly lighting the group. Don't believe me? Let's meter. f2.8, 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 f2.8. So 1, the size of the window is bigger than the softbox I had on my flash, but also the sun is so far away that everything is evenly lit. That's why it's challenging to simulate natural light. We need large softboxes and powerful lights to do so. So I hope you've understood now one of the most important principles of light, the inverse square law, and how to use it to solve lighting problems. It's intuitive, but knowing the science behind it will take the guesswork out of setting up your lights. Speaking of science, here's the mathematical equation. Intensity of light equals 1 over the square of the distance. I hope you learned a lot from that video. For more videos about toy photography lighting, subscribe to my channel. This is 4 Bricks Tall. See you next time.